Welcome back, I'm Chili, and this is lesson 16 of the intermediate game programming series. And we're just chilling out here, gonna continue writing that platformer. First things first, we're gonna do a little segment here called Chili Done Fucked It Up. Because I kind of fucked a couple things up here. We gotta right these wrongs. So I made these two member functions in bidirection. They basically do the same thing. This one is a mutator. It changes the direction of the object. And this one is a constant function that gets the opposite direction. It doesn't actually change the object itself. It just gives us a direction which is opposite to the direction of the object. So one's a mutator, one's constant. So for the constant one, obviously we're going to return bidirection to get the opposite direction. But with the mutator, we're not returning anything. We shouldn't be. We're just mutating the object itself, making it the reverse of what it was before. So this should be void, not bidirection. Long story short, that is fuck up number one. Fuck up number two is the one I told you for your homework assignment. And it lies in bi-surface sequence. Basically, we're dynamically allocating these two sequences here, but we're not freeing them later, and that will lead to a memory leak, possibly. So let's go bi-surface sequence, and let's delete these mothers. Delete left seek. And that is that. We'll build and see if this broke anything. It should be fine. I have faith, because you've got to have faith. And running works fine. Done. Okay. So that is all the fuck ups fixed, and let us get on with making the game. If you look at this here, we can run to the right, but we still can't run to the left. We've created our bi-surface sequence and our bidirection. And we have switched over our sprite system to use them, but we still haven't modified our sprite system to take advantage of the new functionality. So let's do that. And let us start our journey here with sprite state. We're going to change a little bit about the way sprite state handles keyboard events here. On control write down. Now first of all, the events are not going to be direction specific. So instead of right down and left down, we're just going to have dir down, direction down. We're going to include bidirection up here. And down here we're going to make this event handler, we're going to have it accept a argument bidirection. So the argument will determine which direction down has been pressed. And we'll copy this mother, put it down here, and we'll go up, I guess. On control direction up. And same deal, it's going to have a argument here, d the direction. Now there's actually one more thing I want to change. I don't like down and up. I don't like that nomenclature because direction down is ambiguous. Does it mean pressing down on the keypad, or does it mean, pushing down the key? So we're going to change this one to on direction press, and this one on direction release. And give me back my ellipses, you motherfucker. I'm going to copy this on direction press. And let's move down the hierarchy. Now we've got to edit player standing. So we're going to change this one from on control right down to on direction press. Add my semicolon on the end. Actually, I'm not going to do it that way. I'm going to control Z out of this mother. Because let me show you, if I change this, right? And then I try to double click this to go to the implementation. It won't work because the implementation still has the old name. So in order to make my my life easier, I'm going to revert that. Now I can go to the implementation. I'm going to change the implementation first. And while I'm here, I might as well actually change the code. So here we are. If we press a direction key, we're going to move from the standing state to the running state. But we also want to make sure to change our direction so that we are facing the proper direction. Now, let me think here. Yeah, so what we want to do is we want to go core, current sequence, pointer to, set direction, direction D. So we set our direction and then we change state to the running state. Nothing could possibly go wrong. And that is everything for player standing. Now we go to player running. No, first we're going to go back to player standing here. And we're going to do what we did before, which was, if I can find my V, there. Now we change this one. And because we changed it in the implementation, now we can double click and jump back here, no problem. So let's repeat that workflow for player running. We're going to go to the class, and then we're going to click on implementation here. Let's paste. On control direction. Now when we're running, we're interested in release, first of all. So on control direction release by direction D, and here's a problem. I'm fine with this. So if we release the direction key, then we're going to stop running and we're just going to be standing. So now we go here and we want to change this to that. So far, so good. Now, since we've changed our interface here from the way it was before to this situation, we're also going to have to change our controller. We're going to go to the polling function here. Now, first of all, we want to add a new case, which is for the case of pressing left. Now we got to change these names here. On control, dir, press, and dir release. Now this is the right one, so we want to go. What do we want to do here? By direction, make right. I'll just copy and paste that. Copy, paste. And down here we want to do the same thing, but in the other way. So on control C, direction press, direction release. And here we want to do by direction, make left, and make left here. Alright. So that should be our controller all set up. Translating button presses into control events for the sprite. Let's build. Let's see what I forgot. Because, I mean, I probably forgot something, right? Yep. I think I caught an error there. Error. On control direction release member function not declared in Player running. Okay, I forgot to go back there. So we'll just copy this one. Go to player running. We'll paste this here. We'll try that one more time. And we have liftoff. So let's see what kind of bullshit we get up to with this, because it's probably going to be pretty bad. Running right, everything fine. Running left, okay, I just pressed left, but I end up running to the right here. And when I stop, I'm pointing left. So that is a pretty confusing bug. Now I already know what the problem is because I put it in there on purpose. But what I want to do is if you want a challenge, if you're interested, you can pause the video right now and try to debug this error on your own. It'll be an interesting experience, and it's the kind of debugging training or practice that you really need if you're going to be making games, engines, and the like. So if you want to practice debugging, pause the video and try to figure out that bullshit. If not, then I'm going to tell you what's wrong right now. So, let's see here. Moving to the right works just as you would expect it, but moving to the left, if I press the left button, I move to the right with the moving right animation. But when I stop pressing the left button, I end by facing left, which is what you would expect. So the standing part is working fine, but when we're running, when we should be running to the left, we're really going to the right. Now there's a bunch of different symptoms here. Some of them are pretty simple. I'm going to tell you one really simple one here. If I can get player running. Player running, where is it? On update. So here we see on update, it's going to increase the X value no matter what. And that's a problem because, I mean, if you're moving left, you want to decrease the value of X. So we're going to need in here, we're going to need to, in here, we're going to need to check what direction we're moving in, and depending on that direction, increase or decrease X. That is problem number one. But that doesn't explain the fact that our running animation is not facing left when it should be. So what is the problem there? Well, let's go to players standing. We'll go to player standing and we'll go to on control direction pressed. Put a breakpoint here. And we'll see what happens. So I press the left button to start running left, and I hit this thing here. It's gonna set the direction. We've got our current sequence. Let's look at current sequence. I can't see all the information about it, which kind of sucks. Core, current sequence, right sequence. Right sequence, left sequence. Alright, so this is our standing sequence, right? 60 hold frames, number of surfaces 1. This is our standing animation. And we're going to set direction in this by surface sequence. And in fact, we do set it to left. Then we go and we create a new player running. Let's jump into there. Jump out of the new, jump into here. And here when in our constructor for the player running state, we set the current sequence now to point to the running sequence. Current sequence. Whose direction is right? Have you got it now? Yeah. So the problem is that we set, if we're standing and we're going to transition to running, first we set our direction to face left in the standing animation, but then we transition to the running animation, but in the running animation the direction is right. So we set the direction for the wrong animation. That's the problem. So let me just go back here. Yeah. That's the problem. We set it here and we shouldn't. Now there's a bunch of ways that we could fix this. We could probably fix it by just setting the direction after we transition the state. But I don't want to do that for a number of reasons. First off, let's fix the easy problem, and that was the direction in which we run. So we go, where is it? Player running here on update. So in here we want to create a test or something that determines whether we're going to be moving right or left. And if we're moving right, we want to increase the X. If we're moving left, we want to decrease it. So in order to do that, we have to remember what direction we're moving in. So let's go to Sprite Core. And let us add a new variable here, by direction, dir. So dir is going to be our direction variable. It's going to remember what direction our sprite is facing. Now, dir is going to default to the direction, let me think here. Sprite, derived classes, player sprite. It's going to default to invalid. So let's do core.dir is equal to, we're going to default the player as facing right. So that's by direction make right. I guess we could have also just done core.dir.set right. We'll do that. Doesn't matter, either way works. So that's that. Now we have a direction variable in our core, and we have it initialized when we create our sprite. Next thing we got to do is we have to use that that direction variable. So let's go to sprite state, player running, player standing, on direction press. So here we go core pointer to dir is equal to D. So we set the direction to the direction that has been pressed. Makes sense? And that's it. That's all we need for right now. Player running, yeah, that's fine, that's fine. Okay, so now we have a direction variable, and it corresponds to the direction in which we are facing. Now all we need to do is use that variable. So in player running, on update, we have to update depending on the direction variable. Now what we could do is we could go like something like if dir or core pointer to dir dot right and then if it's going right we add, and if it's going left we subtract. But I'm going to do something a little more classy, a little more elegant here. I'm going to get fancy on you guys. Let's go to bidirection, and let's create a new function here. Float transform const if I'm just wondering. If dir is equal to left, okay, we need another float value. Float value. Now if dir is equal to left, can you get what do you catch my drift yet? We return value times negative 0.1f. Else dir is equal to right, return value. I want to return, I'm just going to return 0 right now. But I would like to return like some kind of like nasty value, like not a number or something. But I don't really know what that is. Let me just try something quick here. # include, that's wrong. Include float.h. Let's see if we can figure out something good here. Open document float.h. Float min, float max, float radix. Ambiguous. Signaling not a number. Yeah. Quiet not a number. Negative infinity, negative normal. I really want to put this. I don't really know how to use these. Like, these are floating point values. They can store like decimal numbers, right? But they can also store like special numbers, like -0, +0, negative infinity. I don't even know what normal and denormal are. So, but here we have not a number. So I want not a number for this one, because that will probably show up really nastily in a debug, right? Because let me just go back here. Right, if the value of the direction isn't left or right, then that means it's invalid. So I would like to return an invalid transformation. Does that work? Seems like it might work. So anyways, what this function is going to do, if you haven't figured it out, is we input a value, like let's say a displacement or a velocity, and it will transform it depending on the direction. So if we're facing right, then it'll just return the value as is. But if we're facing left, it'll negate that value. So if you put in a positive number, it will transform it into the direction, the bidirectional vector that you want. Just a one-dimensional vector, right? But if the value of the direction is invalid, I want to return an invalid number to, like, you know, make it easier to figure it out in debugging what went wrong. If I return 0, that might, in many cases, that will just be like the program will still work. It'll just do weird shit and you won't know why it's doing weird shit. So let's try this out. So we create this transform function here. Now let's see if I can go back to where I was before. Go back, go back, go back. Back with you. Back, back, back. Good. Now here, x is plus than or equal to dir dot, scratch that, core pointer to dir dot transform 3.0f. So we transform our velocity, and then we add that to our position, and then we advance the frame. All right, so build this mother. Let's see where my errors are. I have no errors. Let's run. So moving right, no problem. Moving left, we get our proper direction. We still have that animation problem, but our direction is now good. Yeah, doing the moonwalk. I would sing a Michael Jackson song, but that would just embarrass us all. So this time I will spare you, but I can't promise about next time. So now let's tackle the more difficult problem, which is the problem of the sprite running. Now, like I was saying, before I so rudely interrupted myself, where's my thing here? Player standing? Seems alright. We could move this thing here, and we could put it in between here. And that would work fine. Build. At least I think it'll work fine. Let's try it out. Now we're running to the right, no problem. Running to the left, no problem. Except now we're facing right when we run left. So we have like kind of the opposite. Yeah, I don't know. So that'll fix that problem, sort of, but not really. It sort of fixes it, but it sort of doesn't. However, I don't want to use that. I don't want to use this approach of changing the place where we set the direction so that, you know, we appease the state gods and so forth. That is not a viable option, and there's a couple of reasons for that. Reason number one, I don't want to split up this operation and this operation, because I'm going to put them both in a single function, because I don't like splitting shit up. That's reason number one. Reason number two is we're keeping two different states. Oh shit. I can see Control X, Control V. Fuck! Where are my keys? Control X, Control V, Control Z, X, V. There. Sorry about that. We're keeping two different variables to remember direction. We've got the direction variable that's in the core, and we've got another direction variable that is inside of our sequence. In fact, we have tons of direction variables. We have one direction variable for every surface sequence we have. And that's not a good idea, because you have to maintain them all and make sure that they're all pointing in the same direction. And that's just a recipe for trouble. So what we're going to do to solve all of our problems in the whole universe and appease the gods of state is we are going to change the way that bidirectional surface sequence works. We're not going to remember the direction inside of here. That was a bad idea. That was the bad touch, and I apologize. What we're going to do is we're going to pass. Oh, you want to suck my dick? We're going to pass bidirection D to our draw. I'm going to go D, and we're going to pass, surreptitious burp, bidirection D here. And for set direction, we're going to do nothing because we're not setting anything. We don't remember direction. So we've made our bidirection class here a little more lightweight. We have to pass direction every time we call these functions, but whatever. It's like 4 bytes. Nobody gives a shit. It's a single int is basically what it is when we're passing shit. And it'll make our design so much better and so much less bug prone. So that is bidirection or bi-surface sequence done. Now we're going to go and change out the rest of our bullshit. So what do we got? We got Sprite. Sprite draw. Let's go to draw. So here we've got a problem because we don't have our direction all set up. So here we go core.dir. We pass direction in when we're drawing, and that solves that problem. Next is we got to go to player running, I believe it is, and we go on update, and here in advance we need to specify the direction that we're advancing in. So we go core.dir, core pointer to dir, and that should fix that problem. Let's see what I've most definitely forgotten to change. Nothing, apparently. So now we're only maintaining one direction variable. I already did that. Why does it always say it's out of date when it clearly isn't, because I just built it? Now if we run this way, good. Run this way, good. We have exercised the demon. I have exercised the demon. So, yeah, that solved our problem. And it made shit nicer. Now, we still have another problem here. And that is, if you're holding right, and you quickly press left, the guy just kind of stops. And the reason is that in the running state, we're not responding to button presses. But what we want to be able to do is to be able to, like, hold left and immediately switch to right if we want to. How do we do that? Well, we start to handle button presses in player running. So we go here, we copy this, paste that, we go on control direction. I'll put press up here. Press. Copy this. We'll go on release here. Void player running on press by direction D. How do you like them apples? You like them just fine. And now we have to handle direction presses. So what are we going to do? We could just go core pointed direction is equal to D. So if we're handling a key press in the same direction that we're going, nothing will change. We'll just set it, but it'll be the same. But if the key press is in the opposite direction, it'll be set to the opposite direction, just as the Lord intended. Praise the Lord. All right, let's try this out. Press right, we're moving right. Press left while still holding right, now we're moving left. Now go this way. We still have a problem. If I press right, then I press left, then I release right, I stop. Why is that? Why is it when I release right, I stop going left? That is because on player running on release, we just automatically, on any direction release, we automatically enter the standing state. What we want to do, my friends, is we want to go if the current direction is equal to the release direction, then we do this bullshit. And by current direction, I mean the direction in the core, of course. But if the release direction is a direction that we're not traveling in, we don't care. If we're heading left, we don't care if you release the right button, as long as you're still holding the left button. That is all we give a shit about. Now, hallelujah. Look at these controls. They're beautiful. Running in directions, stopping, standing. It's amazing. Aren't you just amazed? I mean, PlayStation 4, Xbone, they ain't got nothing on this shit. So yeah. That is how we handle, that's how we're going to handle control events in the future. And see, this is one of the advantages of using a class for our direction instead of like a simple enumeration or something, is that we can make these functions like transform, and they'll do crazy shit for us and make our code look sweeter and be more maintainable and all that good happy horse crap. So yeah. Actually, I've already got 36 minutes here, so I don't think I'm going to enter into collision in this episode. What we're going to finish off with is we're just going to clean up the code a little bit. We're going to make a couple changes that I wanted to make for a while, but I didn't. So let's make those changes right now. Change the first. If I can find it. First I got to think so I know where I'm going. I want to go to player sprite state. If I look at some code, I'll remember what I want to change. Players standing on direction press. All right, so change number 1 I want to make is, if you look at every single time we change the state, we have to do two things. We have to set the state to the new state, set the core's state pointer to the new state, and then delete the current state, which is the old state. And I don't like having these two steps. If you do it at the same time every time, they should bind them together so that, stuff. Explaining shit is hard. You bind them together so that you don't forget. Like later on, I might be writing a state handler, and I might have a transition, and I might, write the new part but forget the delete part, and that'll introduce a memory leak into the system or whatever. So what I'm going to do is I'm going to make a function that has these two things together. And I'm going to put the function in the sprite state, if I can find it. Where's sprite state? Sprite state. Here it is. So we'll make the function protected. And it's going to be void transition sprite state pointer to state. What should I do? I'll make it inline. It'll be fine. So how do we handle this mother crupper? Now I'm just making words up. So we go to, let's go to player running, I guess. I don't know. Copy some bullshit. And we'll go back. Go here. Delete this. Okay, so core state is equal to state. Delete this. It should be fine. No. This is dangerous. Is it dangerous? If I call delete this, it's going to call the destructor. So I have to make sure that I have a virtual destructor. and that I spell the word virtual correctly. Also important. Do you know why I have to make this destructor virtual if I do this? If you don't understand, come to the forums and ask me. I'm just plugging the forums right now, but seriously though, you should ask me if you don't understand why I have to create this virtual destructor here. Because if I don't create this virtual destructor and I delete this and then I call this transition from a child class, it's gonna fuck things up. It's gonna fuck them up hard. Sometimes. It will sometimes fuck things up. So yeah, I'm gonna create this transition function, and that is going to set the core and delete the current object, the current state object, which is the old one. Then I'm going to go back to everywhere where there was a state transition, and I'm going to go transition and create a new state here. There we go. And it makes the code easier to read now because you understand you're doing a state transition because it says so right there. Self-documenting code at its finest, my friends. Player standing. Let's go here. Oh wait, that was the one I just did. Poopy. Player, this one. And let's go here. We'll do this bullshit again. We'll go back down here. And we will call transition. Let's build. Let's make sure everything works. Nice. Let's see if anything breaks. Didn't break. Nothing broke. Lovely. Fantastic. Look at how beautiful our code is. Isn't it so deliciously good? Doesn't it give you a raging erection? Because I know it does for me. Right now, as I'm recording this. Okay, so now there's one more thing I wanted to clean up, make a little prettier before I call it a day. Before I call it a wrap, we're going to go to Sprite. Sprite Core. Not Sprite. We're going to go to Sprite State. Where is it? Sprite Controller, Sprite Core, Sprite State. And we're going to change this pointer to core. We're going to change that to I wanted that one. Where is it? I think it's a 6. Yeah, it's a 6. Okay, so we changed this one here to a reference. Because we don't need a pointer. We're not going to be like pointing to a bunch of different shit or changing the value later on. The reference is going to be set when we create the sprite state, and it's not going to change throughout the life of the sprite state object. So we don't need pointer functionality. We're really good with just references. It's safer, it's better, it's gooder. It's way better gooder. And it also makes it so we don't have to type this arrow every time we want to access the core. We can type a dot. And dots are faster to type than arrows. I like typing faster because I suck at typing. It is the bane of my existence. So here, I'll do that. Beautiful. And everywhere where we have a pointer here, let's copy this. Now I'm going to go find and replace, if I can find it. Edit. Find and replace. Quick replace. We're going to replace core pointer thing, dereferencer, member access, doohickey with the dot, core dot. And we're going to do that for entire solution. Find next. Replace. 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 Go. 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 Done. It makes me feel better. Core dot. There. Why? What is your problem? Why don't you like me? Why don't you like me anymore? We gotta change this one. What else we gotta change? The best way to find out what we gotta change is just to do it. Just do it. Tell me why you hate me, compiler. I can take it. I'm a grown chili. Okay, obviously you don't like this, and that is completely understandable. What else you don't like? You don't like that? That'll be fixed when I change that. You don't like, what do you know, what's wrong with that? What is wrong with this? Sprite Core pointer to, from Sprite Core to Sprite Core pointer. That'll be fixed when I do this. We've still got an error, but we're getting less errors. Core.state. We don't need this thing here, obviously. Keep it coming. Keep it coming. Yes, we're done. And we haven't broken anything. We didn't really change anything functionality-wise. We just changed our syntax, really. Because a reference is basically the same thing as a pointer. It just looks different and it behaves a little differently in terms of restrictions. Alright, so that is the code looking a little sexier, a little slimmer. Look at all these classes. I love them. I love them all. They're like my children. Alright, so I think I'm going to call it a day here. And when we come back, we're either going to do jumping or we're going to do collision. I haven't decided yet. I'm on the fence, really. But either way, we're going to do something different and interesting, and we're going to program, learn C++, all this good object-oriented shit. This is, what we're doing right now is object-oriented up the bunghole. So I hope you are getting something out of this, because I think it's good stuff. It's pretty good. It's kind of a big deal. So until the next time when we do stuff, I bid thee farewell.